Hello everyone. Today we are covering a topic from IGCSE Cambridge Chemistry, lesson Organic Chemistry, topic Naming Organic Compound. We know by now that in organic chemistry we talk about compounds made of mainly carbon, hydrogen and oxygen. Depending on the number of carbons in the compound and the functional group, there are many different organic compounds. So it's important to indicate both the number of carbons and the functional group when naming the compound. To do this, we use the prefix and the suffix of the name. The prefix is how the name starts, and that will indicate the number of carbons. For example, if there is one carbon, the name will begin with the prefix met. If it's 2, then it will be eth. 3, prop. And it's 4, but. And if it's 5, then hen. The suffix or how the name ends will indicate the functional group. For example, if it is an alkane, we end with ane. If it is an alkene, we end with -ene. If it is an alcohol, then we end with -ol. Finally, if it's carboxylic acid, then we add oic acid to the end. So let's just take a very quick example. If it is an organic compound, which is an alkane with 1 carbon, we called it methane or methane. If it is an alkene with 2 carbons, then it's eth and ene. So it becomes ethene. If it is an alcohol with 3 carbons, then we start with prop, end with -ol. Becomes propanol. And then if it is a carboxylic acid with 4 carbons, it would be butonic acid. Butonic acid. Now let's look at a few more examples. When you see an organic molecule, you should be able to name it. And that's what we are going to try out in this slide. Now let's start with the first one. Here, this molecule has 1 carbon. And you should already notice that the functional group in this molecule is just OH, which means this molecule is an alcohol. So if it's 1 carbon, the prefix has to be met. And because it's an alcohol, it should end with -ol, the suffix -ol. So combining these two together, we have the name methanol. Let's try the second one. There's 2 carbons, and again we have the OH, which is an alcohol. So it's ethanol. Now, if you notice all these, the first row shows alcohols. Only the number of carbons change. Here we have 3 carbons. So we start with prop. That makes it propanol. And finally, there's 4 carbons. So it becomes but. The prefix is but. So the name is butanol. And then in the second row, all of these compounds has the functional group that belongs to a carboxylic acid. And for a carboxylic acid, the suffix or the way you end the name should be oic acid. Depending on the number of carbons, the prefix changes. So the first molecule right here has only 1 carbon, so it starts with meth. Therefore, the name should be methanoic acid. And here we have 2 carbons, so it starts with ethanoic acid. Then we have 3 carbons here, so it starts with prop, becomes propanoic acid. And finally, there's 4 carbons, so the prefix is but, it becomes butanoic acid. Not just that, you should also be able to draw the compound when you see the name of the organic compound. And that's what we're going to try now. Now, the first name that is given is methane, or some people call it methane. Either way is fine. So look carefully. The prefix is met. So if the prefix is met, this means there's only one carbon. And the suffix is ane. Ane means this molecule should be an alkane. So we have to draw an alkane with one carbon. Alkane with one carbon would be just CH4. One carbon with 4 hydrogens in either side. And then we have ethane. Ethane, the prefix is eth and the suffix is ane, which means this is an alkane with 2 carbons. So you draw 2 carbons, connect them together with a single bond, and for the rest of the bonds in carbon, we attach hydrogens. So this is the molecular structure for ethane. Let's look at the next one. Ethene. Now, here the prefix is eth, which means they're talking about 2 carbons. But the suffix now has changed, not ane anymore, it's ene. Ene represents an alkene. An alkene is a molecule with 1 carbon-carbon double bond. So there's 2 carbons with 1 carbon-carbon double bond. That means the double bond between those 2 carbons, the bond between those 2 carbons is a double bond, like this. And for the rest of it, we just add the hydrogens to the sides. Then we have ethanol. Ethanol has the prefix eth again, which means there's only 2 carbons. Nol represents an alcohol. So the functional group OH would be present. So we need a molecule with 2 carbons. The bond between the 2 carbons is single bond. And there's one OH group that is attached to one of the carbons. So we draw the carbon and then attach the OH group first. And the rest of the bonds that carbon can have, we just fill it up with hydrogens. That's how we draw the structure of ethanol. And our final example talks about ethanoic acid. Still, we have the same prefix, which is eth, that represents 2 carbons. And now we have a different suffix, oic acid. If there's oic acid, we're talking about a carboxylic acid, which means the functional group C double bonded O with another OH is present. So we need to draw a molecule with 2 carbons, 1 carbon with a double bonded O and an OH. So we'll draw that first. We draw the carbons. The carbon is bonded to one other carbon with a double bonded O and the OH group. After we have this, then we just have to fill in the rest of the bonds of remaining carbons with hydrogens. In this case, there's only 1 carbon with 3 other bonds that could happen, and all 3 are filled with hydrogens. That's the structure of ethanoic acid. The longer the carbon chain is, the more options the functional group would have to go and place itself. So, which means there can be more than one place a functional group can be at. So, in this case, we use a numbering system on the carbon chain to identify where the functional group is. And not only that, when there are more than a few carbons, then there could be more than one of the same functional group as well. So in this case, we use a new prefix now, di and tri. For example, here, if you have 2 functional groups, we use the prefix di or di. If there's 3 functional groups, then we use the prefix tri, tri. Now, just to understand this better, let's look at this example. We are going to draw 1,2-dichloroethane. Now, first let's focus on what we already know. We know what an ethane is or ethane is. Ethane is 2 carbons with only single bonds. So Just a regular ethane would look like this. Now there's some additional information, right? It says 1,2-dichloro. So first, what is chloro? Chloro is the name for a functional group when there's chlorine instead of the hydrogen. So there's a whenever there's a chlorine atom bonded into the molecule, we call that functional group chloro. So it's not just chloro. If it's just chloroethane, that means there's only one chlorine. But here it's dichloroethane. That means instead of two of these hydrogens, we have chlorine. But we don't know whether it's these two or these two, like this. It could be here or even be here. Could be in either of the carbons or in the same carbon. Now, to indicate this, we have this numbering system. If we number this carbon as 1 and this carbon as 2, if it says 1,2-dichloroethane, that means the chlorines are in both the carbons. So one is in one carbon and the other one is the second carbon. These are two possible ways you can draw it. Chlorines are placed on both carbons. But say if it says 1,1-dichloroethane, then this means both chlorines are on the same carbon. Okay? This way we can figure out where the functional group is and how many of the functional group is present in the same molecule. This gives additional information about the particular organic compound. Now that we have covered the theory for this topic, let's have a look at a few past paper questions. Given below are structures of 4 compounds. Select the answer matching for the 4 compounds. Right, so we just have to name each of these compounds. First, let's not look at the answers and try to name these compounds. Look at the first one. The first one has 2 carbons. If it's 2 carbons, what is the prefix we have to use? Eth. And what is the homologous series that this organic compound belongs to? It only has single bonds, carbon-carbon single bonds, and no other special functional group. So this is in fact an alkane. So an alkane would have a suffix "ane" at the end. Combining these two, we get the name ethane. Go to compound 2. On this 2. 2 also has 2 carbons. So it will be eth. The prefix is eth. What about the homologous series? It has one carbon-carbon double bond and no other special functional groups. So this is an alkene. And because of that, the suffix would be "ene." Combining these two, we have the name ethene. Third one also has 2 carbons. So the prefix would be eth. What about the suffix? See here, we have the functional group C double bonded O and OH. And that is the functional group for a carboxylic acid. So the suffix would be oic acid. Combining these two, we have the name ethanoic. Now let's look at molecule 4. Molecule 4 also has 2 carbons. So the prefix would be eth. And molecule 2 has the functional group OH, which belongs to an alcohol. So the suffix would be ol. When you combine these two, we get the name ethanol. So the correct order of names should be ethane, ethene, ethanoic acid, and ethanol. Let's see if we can find that answer here. Ethane, ethene, ethanoic acid, and ethanol, of course. Here we are. answer number 3 gives the correct sequence. Ethane, ethene, ethanoic acid, and ethanol. Let's look at one final question. Which of these following rows is correct about the names of the organic compounds X, Y, and Z? Now, before we go into the table, we'll try to name these compounds on our own. The first compound, X, has 3 carbons. Because of that, the prefix would be pro. And these 3 carbons are each connected to each other with a single bond and has all other hydrogens around it. How do we know that? Just by looking at it. If you write the molecular formula of this atom, of this molecule, it would be C3H8. And this represents the general formula of an alkene. It goes by CnH2n plus 2. If N is 2, N is 3 here, then the number of hydrogens has to be 8 for an alkene. That's how we know molecule X is an alkene. So it's important to remember the general formula of all the homologous C. So this is why this would have a suffix of ane. So this molecule is a propane. And then we have Y. Y has 1, 2, 3, 4 carbons. It has 4 carbons. And how many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. This is still abiding by the same general formula of an alkene. Because if the number of carbons is 4 and H is 10, which means H is 2n plus 2. 2 times 4 is 8, and then plus 2 is 10. That's how the 10 hydrogens have come. So since this molecular formula is also abiding by the same general formula of an alkene, even Y is an alkene. So since the 4-carbon chain, we have a prefix of but, and since it is also an alkene, we have the suffix of ane. This is a butane. And finally, Z has 2 carbons, which means the prefix is going to be eth. And now here, this is simple. This has a very distinct functional group, OH. OH means it is an alcohol. Alcohols will have a suffix of ol. So this becomes ethanol. So the correct sequence of names is propane, butane, and ethanol. Now, all we have to do is just pick the row with that correct answer. Propane, butane, ethanol. The correct answer is answer A. With this, we have come to the end of the discussion of this lesson. Thank you for listening.